Hello everyone, welcome to your channel Sukh Academy EduWorld. I had already solved first 30 questions of Prelims chemistry exam of Geo-Scientist 2024. Now I'll solve next 15 questions. In the 31st question, they're asking that the formula for the coordination compound amine diaqua chloride of platinum plus 4 tetrachloride of platinate plus 2 is this. Okay, there are four options are available and we have to pick one correct formula for this coordination compound, and to find that we have to just focus on the oxidation number of the center metal atom. Okay, and in the both coordination sphere, in the first coordination sphere the oxidation number of the platinum is plus 4 and in the second case this is plus 2. Okay, these oxidation numbers will help us to find the correct formula. So okay, if we'll find the charge of both coordination sphere, in this case we will use coefficients. See here, this is 1 and 1. So both the coordinations of here, this will get plus 1 charge and this will get minus charge. Similarly, this coordinations of here, according to this is the coordinations of here will get 3 positive charge and this will get 2 negative charge. Okay. Similarly, in this case, this coordinations of here will get 2 positive and this will get 3 negative charge. So here is 2. So this coordinations of here will get 2 negative charge, and according to this coefficient 1, this coordinations of here will get plus 1 charge. So now we have to find that is this okay with this charge. So we will fill this plus 4 charge for the first coordination sphere this, and then chlorine will contribute minus 1 charge, and for ammonia this is 0 and this is for water that is also neutral will contribute 0. So ultimately the total charge of the coordination sphere should be plus 3, but here charge is plus 1, so this statement is incorrect. Okay, the first statement is incorrect. Now come to the second option. In this case, this coordination it is the platinum has plus 4 oxidation number, and for the chlorine this will be minus 1, and both ammonia and water are neutral so contribute 0 charge, so overall charge will be plus 3. Okay, so yeah, in the coordination sphere this also exhibit plus 3 charge. So now we will confirm the anionic part. This for this sphere the platinum has plus 2 charge and there are 4 chlorine, each will contribute minus 1 charge, so overall there will be minus 2 charge on this coordination sphere. That is also okay with this. So okay, our overall charge matches with the charge of the sphere, so the correct answer is second. If we can also check other cases. In this case, consider this plus 4 for the platinum, minus 1 for the chlorine. Okay, and both the for the ammonia this will be 0, and for two water molecule this will again 0, and if overall charge should will be plus 3, but in this case there is a plus 2. Okay, so this option is also incorrect. In this case, take this is plus 4 for the first coordination sphere. Platinum has plus 4 oxidation number, minus 1 for chlorine, and ammonia this will be 0, and for two water molecule this is again 0. So this should be plus 3 and it is exhibit plus 1 charge. So this option is also incorrect. So correct option in this question is second. Okay, second is the correct option, correct answer in this question. In the next question, how many milliliters of 0.25 molar solution of H2SO4 will react with 10 ml of 0.25 molar solution of sodium hydroxide? Okay, and in this case, they are saying that there is a neutralization reaction between sodium hydroxide and H2SO4. Okay, and the volume of the H2SO4 we have to find, and the molarity of the H2SO4 solution is 0.25. Similarly, molarity of the sodium hydroxide solution is 0.25 and the volume used for the sodium hydroxide is 10 ml. Okay, and to find the volume of the H2SO4, we will use molarity equation, that is M1V1 is equal to M2V. Okay, this is for sodium hydroxide. This is for H2SO4. And the molarity of the H2SO4 solution is 0.25. Volume we have to find. Let consider it V1. And the molarity of the sodium hydroxide solution is also 0.25 and the volume is 10 ml. Okay, so we will left with the volume 10 ml. However, we are getting 10 ml volume of the H2SO4 that is required for the neutralization of sodium hydroxide, but this is not the correct answer. For the neutralization of 2 ml of sodium hydroxide, there should be 1 ml of H2SO4 because one H2SO4 contributes to H positive, okay, but one sodium hydroxide contribute one OH negative only. So it means that there should be half volume of the H2SO4 is required to neutralize the double volume of sodium hydroxide. We can also say that 1 ml of NaOH is required to neutralize the half volume of the H2SO4. So, to neutralize 10 ml of sodium hydroxide, there should be 5 ml of H2SO4. Okay, so the correct answer should be 5 ml. Okay, so in this question, correct answer is C. Now, in the 33rd question, which one of the following represents the correct order of the acidity among carbon dioxide, SO2 and SO3? Okay, and to check the acidity, first of all, we will find the oxidation number of the central atom. In this oxidation number of the central atom, central carbon atom is +4. In this also +4. And for SO3 is +6. Okay, and the molecule which has higher oxidation number of the central atom will contribute more acidity. So SO3 has maximum acidity and in comparison to other two. So in this case there should be only first answer. Okay, and if we will compare the acidity of SO2 and CO2, SO2 will be more acidic as compared to CO2. And this question we can understand, this concept we can understand only by hydrolyzing both. Okay, when we hydrolyze SO2, there will be H2SO3, and when carbon dioxide will react with H2O, there will be formation of H2CO3. So if we compare sulfurous acid and carbonic acid, then sulfurous acid is more acidic as compared to H2CO3 carbonic acid, and this acidity we are considering only in the form of releasing of H positive. H2SO3 can release H positive easily. So this is more acidic as compared to H2CO3 because in the H2CO3 SO bond is more polar. Okay, so that's why H positive will be released easily in comparison to in the structure of carbonic acid. Okay, so this H2 sulfurous acid is more acidic as compared to carbonic acid. So the correct answer of this question is A. In the 34th question, which among the following statements regarding Ostwald dilution law is or are not correct? Not correct. Where alpha is degree of dissociation, K is equilibrium constant for dissociation, and C is the concentration of solution. Okay, so we have to pick that statement which is not correct according to the Ostwald dilution law. Since Ostwald dilution law is valid only for the weak electrolytes, not for the strong electrolytes. And in the second option, they are saying that Ostwald's law is valid for strong electrolytes. So this statement is incorrect. And in the first case, activity coefficients are taken as unity. This is okay because in the Ostwald dilution law, the activity coefficient become equal to unity at infinite dilution. And this statement is also correct. Alpha is equal to K over C. Suppose there is any weak acid, let's say acetic acid, it will break into CH3 CO negative plus H positive. Okay. At time t is equal to 0, let's say its concentration is C. Okay. And after dissociation of C alpha, the concentration of anions and cation and parent acetic acid will be C minus C alpha. And when we will take equilibrium constant, this will be concentration of products over reactants. So this will be C square alpha square C minus C alpha. By taking C as a common in the denominator, we will left with C alpha square over 1 minus alpha. But for the weak electrolytes, alpha is always less than 1. So alpha is very small, dissociation constant is very small. So that's why we can neglect that. Ultimately, we will left with this K is equal to C alpha square and alpha will be K over C root K over C. Okay. So this is valid only for weak electrolytes. And both the first and third statement is correct and second statement is incorrect. And in this question we have to provide that statement which is not correct. And so second statement is not correct. So answer should be B in this question. Okay. So B is the correct answer. Now in the 31st question, which one of the following statement is correct? Water is a strong electrolyte. The value of water is strong electrolyte. This is incorrect statement. The value of the ionic product of the water varies with the temperature. This is correct. The concentration of H positive and OH negative in the 10 to the power minus 4 molar HCl solution are same. This is also incorrect statement. And the ionization constant and ionic product of the water are same. That is also incorrect option. So in this question, the correct statement is B. In the 36th question, the pH of the buffer solution containing 6 ml of acetic acid and 4 ml of sodium acetate solution will be approximately. In this case, we have to find the pH of the buffer solution. Okay, in this case, we have to find the pH of the buffer solution. And for the weak acid, pH of the buffer solution is pKa, pKa plus log of salt plus acid. We can calculate pH value. In the case of acetic acid, its concentration molarity of the solution is 0.2 molar and volume is 6 ml. For sodium acetate, molarity of the solution is also 0.2 molar and volume is 6 ml. And similarly, they are providing value of log 2 that is 0.30. pK value for the acetic acid is 4.76 and for value of log 3 is 0.48. Okay, so first of all we will find the concentration of salt. Concentration of salt. Okay, and acid. For the acetic acid, there is 6 ml volume, 6 ml with 0.2 molar molarity of the solution. First of all, molarity means mole per liter. It means pointed molarity is 0.2 mole per liter. Okay, so can we replace molarity by mole per liter? Okay, similarly convert this 6 ml into liter. When we will convert this 6 ml, to convert that we will divide it with 1000 and we will get this value in a liter. So ultimately this will be cancel out. Okay, so we will left with 0.0012 mole. This is the this moles for acetic acid, concentration of acetic acid. Similarly, to find the concentration of salt, convert volume of the sodium acetate into liters and divide it by 1000, and here is also 0.2 molar solution, that is mole per liter. We can also replace molar by mole per liter. This liter will be cancelled out. So ultimately we will left with 0.0008 mole of salt. Okay. So now we will fill this value here. So pK value is 4.76 plus log of concentration of the salt is 0.0008 and concentration of the acid is 0.0012. Now we will solve it. Log of 8 over 12. 4 2 is 8, 4 3 is 12. Log of 2 over 3. Now we can write it as 4.76 plus log of 2 minus log of 3, and value of log 2 they are providing us in the question, that is 0.30, and value of log 3 is 0.48, and after solving it we will get 4.58 pH of the buffer. So in this question the correct answer is C. In the 37th question, which one of the following doesn't represent a correct expression for hydrolysis constant for the equilibrium reaction? This. See, in this case, the equilibrium for this reaction, for this reaction, equilibrium constant will be, or hydrolysis constant will be, concentration of products over concentration of reactants. Okay. And water is our solvent. Its concentration is equal to 1. So hydrolysis constant is OH negative, Ha, and concentration of R anion. Okay, so this is also available in the option. We have to show which one of the following does not represent a correct expression. Okay, so this is our correct option. We have to provide that is not correct. Now come to the another part. This is a acid, let's say. Okay, For this, SD constant will be again concentration of product over reactant, and ionic product is of the water is H positive, OH negative. See, in the third part, they are saying that Kw ionic product over Ka is equal to Kh. Kh is equal to Kw over Ka. Okay, so we have both values. We will divide it. Kw over Ka. So this is also our hydrolysis constant, that is this, okay, Kh. So it means Kh is equal to Kw over Ka. This statement is also correct. Okay, it means C option is also correct. Kh over Kw Ka, and similarly we, by taking log both sides, we can calculate, we can find this value from here. So A, B, C, these three statements are correct. The statement which is not correct, that is D. Okay, because our hydrolysis constant also contain a concentration of A negative in the denominator, that is missed in the D option. Okay, so in D option is our correct answer, because we have to show, we have to check that option that is does not represent correct expression. So D is our correct answer in this question. In the next question, which one among the following compounds does not form primary standard solution? Okay, in this question, the correct answer is B, that is sodium hydroxide, because sodium hydroxide solution of non-strength can't be prepared by weighing, as it combines with carbon dioxide and moisture to give sodium carbonate. It can combine with carbon dioxide and moisture and will give sodium carbonate, whereas primary standard is a reagent that is pure and representative of number of moles the substance contains and that can be easily weighed. Okay, so in the case of sodium hydroxide does not form primary standard solution. So in this question, the correct answer is B. In the 39th question, while performing the titration of the KMNO4 with clear more salt solution, a student obtained brown precipitates in the conical flask instead of colorless solution. Much before the endpoint was reached, what could be the possible source of error? Okay, four options are available. First is reaction mixture was not heated to 60 degree. This statement is incorrect. Reaction mixture, this is unlikely to be the cause of the brown precipitates, because the temperature of the reaction mixture doesn't strictly affect the formation of the brown precipitate. In the second option, Fe2 positive in the Mohr salt solution hydrolyzed to precipitate brown hydroxide. Similarly, in the third option, reaction medium was not made acidic. In the second option, the brown precipitates is likely due to the hydrolysis of Fe2 positive ions in the Mohr salt solution, whereas Fe2 positive ion react with water, they form brown ferric hydroxide, and this premature reaction can occur only if Mohr salt solution is not properly acidic. So ultimately, in this question, there is a probability of both B and C, both B or C option to be correct. So according to me, the correct answer should be C. in this question. In the D option, too large quantity of KMnO4 had been added to the Mohr salt solution. While adding an excessive amount of KMnO4 could lead to other issues, it is not directly responsible for the brown precipitates observed. So ultimately, there should be a two option, B and C. However, C is the main reason for the formation of the brown precipitates. So C is the correct answer in this question. In the 40th question, in which one of the following titrations are metal ion indicator used? Okay, so in the correct answer is complexometric titrations. In the 41, in the next question, the total kinetic energy of 2 moles of an ideal gas at temperature 300 Kelvin is approximately. Also, we have to find total kinetic energy. Okay, and to find the total kinetic energy, that is equal to 3 over 2 nRT. 3 over 2, and n is the number of moles that are in this question. There are 2 mole. Okay, value of R is 8.3 joule per Kelvin per mole, and temperature is 300 Kelvin. Okay, and Kelvin, this is Kelvin inverse and this is Kelvin. Both will cancel out with each other. Similar, this is mole and this is mole inverse. So we can cancel each other. So ultimately, our answer will be left with the unit joule. And when we will solve it, this will be 7470 joule. Okay. So we can also rearrange this and our answer will be 7.47 into 10 raised to power 3 joule. That is almost equal to C option. Okay, so in this question, the correct answer is C. In the next question, the root mean square velocity of 1 mole of an In the next question, the root mean square velocity of 1 mole of monoatomic gas having molar mass is m and root mean square value is u. The relation between root mean square and the average kinetic energy E of the gas is. Okay, so root mean square velocity is equal to root 3 RT over m. M is the molecular mass. Okay, so kinetic energy is 3 over 2 RT for monatomic gas. So they are representing the average kinetic energy as E. So E is equal to 3 over 2 RT. In this case, we can consider 3 RT will be equal to 2E. Okay. So fill this value of 3 RT into this equation, first equation. So root mean square will be equal to 2E over m root. Okay. So this will be the correct answer. B. B is the correct relation between root mean square velocity and average kinetic energy, that is E. So B is the correct answer in the 42 question. In the 43rd question, consider the following statements regarding kinetic energy of gas. The first statement is at 25 degrees Celsius, the average kinetic energy of hydrogen gas molecules is same as that of helium gas atoms. So this statement is incorrect because the helium gas is monatomic. Okay, and its kinetic energy will be 3 over 2 RT because it will exhibit only 3 translation degree of freedom. So its kinetic energy will be 3 over 2 RT. However, in the case of hydrogen gas molecule, that is diatomic gas, so it will possess both translation and rotational motion, so will contribute into kinetic energy. So overall, for hydrogen will be 3 translation degree of freedom. So 3 over 2 RT plus there are 2 rotational degree of freedom. So 2 over 2 RT will be kinetic energy from rotational motion. So overall, the average kinetic energy for the hydrogen gas molecule will be 5 over 2 RT. So these two values are not same. So statement 1 is incorrect. Thus, in the second statement, the average kinetic energy of the gas depend on the temperature and doesn't depend on the nature of gas. This is correct statement. Average kinetic energy is always directly proportional to temperature. It does not depend on the nature of a gas. Okay, so first statement is false and second statement is correct. So in this question, first statement is false and second statement is correct. D is our correct answer. In the 44th question, consider the following van der Waals constant values of two gases, X and Y. Okay, for A and B, which one of the following is correct with respect to the van der Waals constant value of X and Y in the table? Okay, so the correct answer of this question is A. X is more easily liquefied than Y. This is because A van der Waals constant gives an idea of the magnitude of the attractive forces between the molecules of gas. Okay, as the value of A increases, the intermolecular force of attraction also increases. So consequently, ease of liquefaction of gases also increases. So with the increasing A gas can be easily liquefied. Okay, so for the X gas A value is large as compared to that of Y. So X is more easily liquefied than Y. So correct answer is we have to pick one of the following statement which is correct. So A is the correct answer in 44th question. In the 45th question, consider the following statements regarding speed distribution of the molecules. This question is related to Maxwell's distribution of molecular speeds. First statement is total area under the plot of this versus velocity u is a measure of total number of molecules in this collection. This statement is correct. In the Maxwell distribution of molecular speeds, in the expression, there is a relation between 1 over n dn over du and u, and this graph is look like that. Okay, and this factor represents the number of the fraction of the molecules. Okay, so the area under this curve represents the total number of molecules in a particular fraction. So the total area under the plot of this versus this measure of total number of molecules in the collection or in the fraction. Okay, so first statement. In the second statement, the curve at any temperature is parabolic near the origin. This statement is correct. However, the with increasing temperature, velocity is increased and the curve will shift toward the right direction and also becomes little flat, but it will become parabolic near the origin. So this statement is correct. In the third, the majority of the molecule have speed which cluster around the average value u in the distribution curve. This statement is incorrect because the majority of the molecules have speed with respect to this peak is most probable speed. Okay, not average value of the speed. So a majority of the molecule contain most probable speed, not average speed. So this statement is incorrect. So in this question, the correct answer is for statement 1 and statement 2. That is A. So A is the correct answer in this question. Okay, students, remaining questions we will cover in the next video. If you have any doubt or query, you can write that in the comment section. And don't forget to like, share, and subscribe this channel. Thank you.